Hello, today I'm going through the QCAA Physics Paper 1 from 2022. You will need, if you're going to go through this with me, a calculator and a formula book. Alright, so let's start with question 1. This question is about electromotive force. Now, electric motive force could be easily confused with electromagnetic force, one of the four fundamental forces in our universe. Electromotive force is similar, but it is not electromagnetic force. So you can see clearly the answer is not D. C is also describing the electromagnetic force, or part of it. So we're down to A or B as the answer. Now, most people, when answering this in 2022, picked either A or B. Quite a few people picked A, the production of voltage, but that is not electromotive force. If you're thinking about a magnet and a coil, electromotive force is B, a difference in potential that tends to give rise to an electric current. Okay, let's have a go at question 2. A photon is best described as... Now, before I read out the answers, the word photon, it basically means packet. So a packet of light, aka a particle. So we have a look. Do any of these clearly say it's not a particle? So part A doesn't, it says it's a wave, so that's not a photon. A photon is not a wave. Then we've got B is a particle that only propagates in a medium. Most people know that a photon, light, doesn't need a medium, so B is also incorrect. Now let's have a look at D. A particle, because again, a photon is a particle that mediates the forces between protons. It's not a gluon. That's left C, a quantum, which is another word for packet of light, of all forms of electromagnetic energy. So hopefully you know that light is an electric field and a magnetic field propagating through space. And so that's clearly C. Question 3. So this is a kinematics force question. So we've got a force on an inclined plane. It's being pulled up at a constant speed. So going up the plane at a constant speed, there's no acceleration, which is the key to this question. Now, if we look at the diagrams, there's two that are clearly wrong. First, friction acts in the opposite direction of force, going along a plane. This one, C, clearly it has its friction going the wrong way. So that's wrong. D is also clearly incorrect because you can see when we look at vectors, the arrow going up the plane, FT, is too small. And so that would not work. That would not go up the plane. It would fall down the plane. So we're left with A or B. So the key to A and B is Fg, force of gravity, is split into the horizontal, going down the plane, and the vertical, going opposite the normal force. So if you add the friction force and the force of gravity, if you add those two arrows together, they need to be the same length, I suppose, as Ft. In part B, the friction force arrow is too big. So if you combine that with Fg, that's going to pull it down the plane. So it has to be A. When you combine the friction force and the gravity arrow, they would be about the same length as the Ft arrow. Alright, so question 4, here we go. An object orbiting Earth has an orbital period of this. What is the object's orbital radius? So we need to look at our formula sheet. If you go to Gravity and Motion on page 3, you'll get the formula which has a capital T for orbital period and it has a little r for orbital radius. But it also has G and M in this, and you'll need those from page 5. So if we sub these into the calculator and rearrange for little r, you should get the answer. So we have to use brackets, 5.6. All right, that's t squared. Now we're timesing that by g, capital G, negative 11, times that by the mass of the Earth. So if we rearrange the formula, we divide that by 4 pi squared. So that's given us r cubed. So we need to do the cube root of that. And so you'll end up with answer B. Okay, question 5. Tau particles are classified as... Now, if you don't know what a tau particle is, we can just have a look at these different ones. So we've got bosons, leptons, mesons, baryons. Bosons are particles that mediate forces. So it's not A. I know it's B because you can also call tau particles, they're often called tau leptons. So it's B. Question 6. So this is talking about the double slit experiment. Quite a famous experiment. Definitely recommend reading up on it if you haven't already in preparation for physics. And this experiment shows the wave nature of light. So it's definitely A. It's not B because equal widths, it doesn't explain. So the key is explained by the. So the width size doesn't explain it. The experiment doesn't show packets of photons. And it's not D because the distance also doesn't explain the nature. I guess a bit more detail behind this. When you do the experiment, there are bands that appear on the wall and not packets of light if they were photons. So these bands show that it's acting more like a wave instead of, a packet of photons, which would show quite a different result. All right, question 7. So this one's all about magnetic field strength. What would produce the greatest increase? There are different formulas for magnetic field strength, capital B. So if you look at B equals mu 0 Ni, increasing little n, the number of turns in the solenoid, that's going to increase the magnetic field strength. So the answer is C. Okay, question 8. Determine the wavelength of an electromagnetic wave with energy of blah, blah, blah. Okay, so we've got an electromagnetic wave, that's light. Hopefully you're familiar when you did the quantum unit with this formula here. Wavelength equals C divided by frequency. We also have on the formula sheet E, which is energy, is equal to hf. So we need to figure out F, and then we can figure out the wavelength. So on your calculator, so type in E to the negative 23. Divide that by h, Planck's constant, which is on page 6 of the formula sheet. Now that gives us our frequency. So we've got our F. We now need to do C divided by F to get the wavelengths. C is the speed of light. And we divide it by F, and that gives us our wavelength. So if you look at this with significant figures, you get the answer C. Moving the decimal place 3 places, it's 8.3 times 10 to the negative 3. All right, question 9. Here we go. This is projectile motion question. So this is again a great question representing 2 that are clearly wrong and 2 that could be right. So C and D have velocities which are less than A and B. So clearly they're not right. Less velocity, you're going to travel less distance. So it's either A or B. The question is, which angle gives the furthest horizontal distance? So traveling along the horizon. A fact that you should know 45 degrees is the optimal angle for the furthest distance. So because they're about the same velocity, one would think B is going to travel the furthest distance. You can do calculations for this, but I would select B. Question 10. Halfway, or nearly, electric field strength refers to, is it A, B, C, or D? Intensity of an electric field. That sounds like electric field strength. B, change in potential energy. That's not electric field strength. A change in electric potential energy is a change in voltage. C, the sum of electric charged particles passing a point. That's current. D, physical property of an object, experience of force in an electromagnetic field. It's not a physical property, so it's A. Question 11. The maximum kinetic energy of an electron ejected from a metallic surface can be increased by... Now this is interesting. We've got positively ionized metal, A. We've already got a metal and ejecting an electron, so that's not going to do anything. Using a metal with a larger work function. So this is when we need our formula book again, quantum theory. So if we have a larger work function, that's going to decrease our kinetic energy, increasing the intensity of the incident light. So I don't know if you've ever read about threshold frequency. When you look at threshold frequency, the fascinating thing in quantum is that as you increase the intensity, it doesn't actually necessarily eject light. So increasing the intensity is not going to increase the kinetic energy. Decreasing the wavelength, however, if you look at the formula, decreasing the wavelength is going to increase the kinetic energy, because kinetic energy equals hf minus w. As we discussed previously in question 8, f equals c over wavelength. So if we decrease the wavelength, that's going to increase f, which is going to increase the kinetic energy. So the answer is D. Question 12. An object experiencing uniform circular motion. So this is a mathematical question. We need our calculator again. Okay, so if you look at your formula sheet on page 3 under gravity and motion, we have V equals 2 pi r divided by t. T is the time for a complete rotation. V is the velocity, and we can use average speed for that. We don't really care about direction in this question. If we rearrange for r, that will give us our radius. So average speed times rotation time divided by 2 pi will give us our radius. So let's put this into the calculator. 8 meters per second. Meters per second is the SI. We've got 0.3, which is also seconds, SI divided by 2 pi. So we get letter A. Okay, question 13. We've got some numbers here. Probably going to need a calculator, our formula sheet. And it's asking us to calculate the minimum number of revolutions. So it looks like it's given us little n. It's given us the area, or the dimensions of the area at least. It's given us B, that many Tesla, converted it to SI, divided by 1,000. And it's given us the EMF. So we need to sub this in to page 3 of the formula sheet. So if we bring the EMF down here, bring the T up here, substitute in, we should be able to get our change in T. All right, little n times B times the area divided by the EMF. These are all standard SI units. So that's the change in T. Now this is the time it takes to go from 2 microteslas to 0 microteslas. So it's done a quarter of the rotation. So you need to times that by 4 to get a full revolution. And then to get how many revolutions per second, you basically invert that. So you do 1 divided by 0.08 and you'll get 12.5 revolutions per second. And that's closest to the answer C. All right, question 14. We've got a standard model question. Feynman diagrams. So it's looking for neutron decay. In case you didn't know what that is, it's a neutron decaying into a proton. So the up, down, down, or UDD represents a neutron. And so we're looking for a decay into a different baryon. So this isn't correct because it hasn't changed. It's still a neutron. So B could be correct, or C. So they've both decayed into something different. And D is clearly incorrect. So we're left with B or C. Now, basically, the only difference between B or C is the type of boson. And so you just have to know that it's a negative W boson. That is the force-mediated particle that comes out. So the answer is C. All right, question 15. An object's velocity can only be measured relative to a fixed reference frame, the speed of light, an object at rest, or an observer. A fixed reference frame is incorrect. The object can't be measured from a fixed reference frame. The speed of light. Well, if you're traveling at the speed of light, you can't measure an object's velocity. An object at rest. Now, lots of people went for C, which is incorrect. It's an observer. All right, question 16. Two vectors are shown, x and y. We need to figure out what's the combination of these two vectors. So a great way to think about this, x plus y, is doing it visually. So we've got x, and then at the end of x, y is happening like that. Now x is slightly shorter than y, that's important. So now we've ended up with an arrow going in that direction. X plus y. It's important that wherever x finishes, that's where y begins. And this is the combination vector. So it could be A, can't be B, can't be C, could be D. So it could be A or D. So we have to figure out either the combination magnitude or the combination direction. So I would pick D. If you look at the diagram, this is based off the arrows given. You can use the non-right angle cos rule to figure out and substitute in this angle and this measurement in D to figure out that D is correct. All right, question 17. An object is in orbit 400 kilometers above the surface of the Earth. The Earth has a radius of this. What is the magnitude of the gravitational field strength experienced by the object? So we're going to need our formula book again. Here we go. So turn to Gravity and Motion, page 3. It's given us the radius of Earth. And if we add the 400 kilometers to that, we're going to have the total radius. So we're going to substitute that in to find little g. We've got gm divided by r squared. G is on page 5, the gravitational constant, times by the mass of the Earth, divided by, okay, so we need the radius squared. So we need everything in meters. So 400 kilometers, add 3 zeros to that, plus 6.4 times 10 to the 6, and then we're squaring that. And so the closest answer to that is A. So just be wary of that conversion, kilometers to meters, and then adding that to the Earth radius to get A. Okay, question 18. The primary and secondary coils for a lossless transformer are shown. So transformer question. So the primary has less loops than the secondary. So this is called a step-up transformer. So this is going to increase the alternating voltage. So compared to the primary coil, the secondary coil will experience decreased. So if you look at your formula sheet, under electromagnetism, page 3, there's IPVP equals ISVS. And so if we increase the voltage of the secondary coil, that means to keep it equal, that means the I needs to decrease. So the answer is B, current. Question 19, coming near to the end, 2 left. A current carrying wire is placed perpendicular to 2 magnets. As the current in the wire is changed, the force acting on it is recorded. So we have force on the y-axis, current on the x-axis. So if you look at the formulas in electromagnetism again, page 3, you get F equals Bill sine theta. The wire length is staying the same and the angle is staying the same. So that means the only thing that's changing is B. So if we do F divided by IL sine theta, capital B, which is answer D for 19. The last question, which option lists the gauge bosons in ascending order of strength of force they mediate? So gluon is with the strong nuclear force. So the gluon has to be the greatest. So it's either C or D. Next, electromagnetic is the second strongest, and electromagnetic force has a photon. So it has to be D. D is the correct answer for question 20. I hope that was helpful. Thanks for watching.